All right, welcome back. Today we're going to be talking about how to use a BA2 Plus calculator for financial mathematics. All right, so here I have the list of all the different things that I'm going to show you how to do on this calculator. And of course, this list does not include every single thing that you can do with this calculator. This is just all the most important things that I think you should be able to know how to do on this calculator in order to succeed in a financial mathematics course. And so if there's a specific function of this calculator that you are interested in knowing, feel free to check the chapters on this video where I have each of these topics labeled so you don't have to skim through the video to find what you're looking for. Just click on the right chapter and you will learn how to use the calculator for that specific topic. And by the way, I'm going to have a lot of examples in this video that are pulled from my own series here on YouTube where I cover various topics in financial mathematics. And so if you're interested in actually watching those videos, I'll have a link to the playlist for that in the description of this video. All right, and so with that, let's just get into how to use the BA2 Plus calculator. All right, so we're going to start off with some basic operations. These are some of the buttons that I believe you should know how to use. They're going to help you to do a lot of calculations a lot quicker. All right, so if you look at the right-hand side of your screen, you'll see that we have the BA2 Plus calculator here. And the first thing that you want to do with your calculator is turn it on. And the on and off button is located at the top right-hand corner. And so if you press that button, your calculator should turn on. All right, and so then if you look at the right side of your calculator here, we have our basic operations. We have division, multiplication, subtraction, and addition, and then of course the equals button that lets you know what things are equal to. So for example, if I wanted to know what 2 plus 2 is, I could hit the 2 button, and then hit plus, and then hit 2 again, and then hit equals, and now we know that it is equal to 4. That's not 40, by the way, that is 4.0. I currently have the calculator set to display 1 decimal, but I will show you how to change that later on in this video. Okay, and so we could use the division, multiply, and subtraction buttons in a similar manner to the way we used the addition button. And so that covers the first 5 buttons here. Let's talk about this next button, the plus or minus button. And what that button does is it either adds or removes a negative sign to a value. So let's say I wanted to make this 4 negative. I'll hit this plus or minus button, and now we have negative 4. But remember, let's say if we clear our work here, if we wanted to add 2 and negative 2, you would have to press 2, then the negative button, or the plus or minus button, and then hit plus positive 2, and that equals 0. Right, so you can't hit the plus or minus button first. Even though we say negative 2, you still need to input the 2 first, and then the negative sign. You can't do it the other way around. That's just how this calculator works. Okay, now you already saw me do it once, but this button right here, this CE and then /C, is the clear button. So if I press that, it clears our work, and we're back to 0 in our calculator here. All right, the next button we're going to be looking at is the percent button. And so if you look at your calculator here, the percent button is right here. And so what that button does is it will give you the percentage for a specific value. So for example, let's say I had 30% and I wanted to know the decimal value for that. I would hit the percent button and we are told that it is 0.3, which checks out because 30% is 0.3. Okay, so that's a pretty simple button to use. So I'll clear my work again. And we can move on to our next button, which is the square root button. And that button is located right here. And so let's say that we wanted to know the square root of 9. I can plug in 9. And then if I want to take the square root of that, I will press that button. And we're told that it's 3. All right, so that makes sense. The square root of 9 is 3. All right, so I'll clear our work here. Let's move on to our next button, which is the x squared button. What this button does is it will square a value for you. So let's say I wanted to know what 100 squared is. So I'll type in 100 like I just did there. And then we'll press the squared button, which is located in the middle of the calculator. So we'll press that. And now we can see that 100 squared is 10,000. All right, so we'll clear that. And we'll look at our next button, which is the 1/x button. And that is located right here. Now I said 1/x. What it's actually called is the reciprocal button, because what it does is it gives you the reciprocal of a value. Now, of course, it gives it to you in decimal form, not as a fraction, because this calculator only works in decimals. So let's say we have the value of 2, right? Remember that the reciprocal of a fraction is just swapping the numerator and the denominator. So 2 would be the same as 2 divided by 1, And so the reciprocal would be 1 divided by 2, which is a half, and that is equal to 0.5. And so if we hit the reciprocal button right here, it gives us 0.5. All right, so that's what that does. Now, if we were to press that again, we would switch from 1/2 back to 2, right? So if we press that button again, now we took the reciprocal of 1/2, and now we're back to 2. So that could be a very helpful button depending on the type of calculations you might be doing. All right, so we'll clear our work again. And now let's look at our next button, which is the y to the power of x button. And what this button does is it takes a value and raises it to another power. So let's say we wanted to take 2 to the third power, right? That would be equal to 8 because 2 cubed is 8. And so I'll plug in 2, and then what we'll do is we'll press that power button, y to the power of x. I'll press that, and then I'll press the 3 button. That's telling the calculator that you're taking 2 to the power of 3, and then you will hit the equals button, and you can see that it is equal to 8. All right, so that is what that button does. I'll clear our work once again. And now we'll look at the next button, which is the natural log button, or the LN button. And that button is located right here. And so when you press that, it will take the natural log of whatever value you have in your calculator. So for example, let's plug in 2 again. If I want to take the natural log of 2, all I have to do is press that button, and the natural log of 2 is equal to 0.7. Now, there are more decimals there, but since our calculator is only set to display one decimal, it's just 0.7 at the moment. But if I had it to display more decimals, then there would be more decimals on the screen because the natural log of 2 is not just 0.7. All right, so that's what that button does. And so with that, that is all the basic operations that I wanted to cover for this specific video. Of course, there are more operations that you can do, but a lot of them I find aren't very important for a financial mathematics class. The last button that I do want to cover, though, before we move on to our next topic, is the second button, because that is a very, very important button that allows you to access all different kinds of functions for the calculator. And so the second button is located right up here. It's the orange button for my calculator. Your calculator might have a different color, but mine is orange. And what that button does when you press it is it will put up second in the top of your calculator there. And what that's telling you is it is now looking for second functions for the buttons on your calculator. And what you'll notice for almost every single button on this calculator is that there is some orange text above each of the buttons. And so when you press the second button and then press one of the other buttons on the calculator, it's not going to do its normal function, it's going to do its second function. So for example, if I were to press this button down here, the plus or minus button that we used to put a negative sign in front of our value, if I press this now because I have the second activated, it's going to instead reset the calculator. And so let's do that. Let's see what happens. I'll hit that button. And now it's asking us if we want to reset our calculator, but we don't actually want to do that, so we're not going to hit the enter button, which is what you would do in this case. And so now I'll just clear our work here. And now we're back to where we were before with our zeros. All right, so that's what that does. The second button allows you to access all the other different functions for this calculator. And you'll notice that that gives you access to the sine, cosine, and tangent functions if for some reason you needed those, but I don't think I ever needed to use the trig functions while working through a financial mathematics course, so that's why I didn't really cover those in detail, but they are there if you need them. All right, and so with that, that is all the basic operations that you need to know for the BA2+ calculator, and so let's move on to our next topic. All right, so next up we're going to be talking about setting the decimal places on the BA2+ calculator. Now, I alluded to this earlier that we currently are only displaying one decimal place. That's not going to be helpful for the majority of a financial mathematics course. You're going to want to see a lot more decimals so that you can have the most accurate answer possible when you solve different problems. All right, and so I have the sequence of actions that we are going to take here to change the number of decimal places that are displayed. And so what we're going to do is we're going to hit the second button, and that's the button that we were just talking about, which is right here. So I'll press that. And then what we're going to do is we're going to press the decimal button, which above it says format. And so over at our calculator, here is the decimal button, and right above it, you can see that it says format. And so because the second button has been pressed, we're not going to be using a decimal. Instead, it's going to perform that format function. And so I'll press that button, and now it says that DEC, or the decimal places that are displayed, is equal to 1. Now, what we want to do is change that to a different value. Specifically, I'm going to change it to display 8 decimal values because that's my preference, but of course you could set less or more than that. I think there is a limit to the amount of decimals you can display, but I don't really see a need to display more than 8. I think 8 is kind of a good number, and so I'm going to press 8, and then I'm going to hit the Enter button, which is right up here. So I'll hit Enter, and now DEC, or the decimal places, is equal to 8, and you can see that the number of decimal places already changed, right? Before it was 1.0 because it was displaying one decimal. Now it's 8.000000 because we are displaying 8 decimals. Okay, and so now that we have done that, we can hit this second button again, and then hit the CPT button, which says quit above it, and that will quit out of the format menu. All right, and so that is how you set your decimal places for the BA2 Plus calculator. Next up, we're going to talk about how we store and recall values on this calculator. And so there's going to be 2 different buttons of interest here. We have the Store button, which stores values, and the Recall button, which will recall the values that we stored. And so let me show you first how to store a value using this Store button. So for example, let's say that we wanted to multiply 8 times, let's say 5.6231, right? That gives us a pretty complex answer that I don't feel like trying to remember in my head. So what I can do is if I need this value for another calculation is store it in the calculator. So what I'll do is I'll press this STO button, the Store button, and then what you want to do is choose a place to store it. Now, we have 10 different places that we can store values, and we store them in the 0 through 9 buttons, right? This button, this 0 button, and then these 9 buttons in here. We can store a value in those buttons. So you can choose any of those 10 buttons that you'd like. I'm going to pick the 7 button just for this demonstration, and now it should be stored in that 7 button. Now, if we clear our work and we want to see if it was actually stored, what we can do is try to recall that value using the Recall button. And so what we want to do is hit that Recall button, which is right below the Store button. So I'll hit RCL or Recall, and then we will hit the 7 button, and lo and behold, there is that value that we stored. Now, let's say that you stored a bunch of values in those 10 different buttons, but you can't remember where a specific value is, and you don't want to waste time recalling values trying to figure out, where's that one number that I need? Well, what you can do is you can actually check the memory of the calculator or check the stored values that you have. And so what we'll do is we'll hit the second button and then the memory button, and then you'll be able to use the arrow buttons to kind of look through your memory. And so here's how that works. Let me first just clear our work here. Let's hit the second button, and then we will hit this 0 button, which says memory above it, right? That's what the MEM stands for. We'll hit that button, and now we're in the memory menu. Now this might look a little different for you because you might not have any values stored in the other buttons of your calculator, but I do. I have whatever this number is right here, 7.36, stored in my 0 button. That's what this says. The memory for the 0 button is this number. Now, if I use these arrows here, this up and this down arrow, I can kind of scroll through the different values that I have stored in the calculator. And so if I press this down button, we can see a value that I have stored for the 1 button, right? That says memory 1. And so this 1 button right here has this value stored in it, which is some other number that I used in the past. But I can continue to scroll through by pressing that down button and look at all the different values that I have stored in my calculator for each of the 10 buttons. All right, and so then it comes back to 0 once you get to 9. Now I can also use the up button if I want to go the other way, but the buttons kind of work the same way. They just scroll through your different stored values. All right, so then if you want to get out of this menu, there's a couple things you could do. You could just hit the clear button a couple times, but the more efficient way is to hit second and then quit, and now you're out of that menu. Now, there is one more thing that I want to show you in regards to the memory and stored values, is that there is a way to clear your memory or remove all the values from your storage slots. And so, in order to do that, you first need to be in the memory menu, and so I'll hit second and then memory. And then what we can do is hit second, clear work. And if we press that, we have now cleared all of our memory, and so if we scroll through our values, I now have no values saved in this calculator. All right, so I'll hit second, quit, and now we are out of that menu. All right, and so then one more thing I want to show you is, let's say that we had all of our storage slots filled, but I didn't feel like going through and clearing my memory before I store another value. What you can do is actually just overwrite a stored value. So for example, let's say I have 56 and I store that in the 8 button. And so if I clear my work here, let's just check to make sure that that is in there. I'll hit recall 8 and there's 56, so we're good. So let's clear that again. I can actually overwrite the value that I have stored in 8. So watch this. Let's say I have 23 and I want to actually store that in the button for 8 and overwrite that 56. I can hit store 8, and then if I clear my work, we can recall 8, and now it gives us 23 instead of 56. Okay, so that's how that works. And so that's really all you need to know about storing and recalling values in the BA2 Plus calculator. All right, so next up we're going to be talking about how to calculate a future value problem in the BA2 Plus calculator. And so here I have an example from my first lesson video in my financial mathematics series where we calculated the future value. I have that you deposit $600 into an account that earns compound interest at a rate of 4% per year. How much will you accumulate in 5 years? And so your initial deposit was equal to 600. The number of periods n is equal to 5 because we're looking at 5 years. And the interest rate was equal to 0.04 or 4%. All right, and so the buttons we're going to be using on our calculator to calculate the future value are these white buttons that you see in a row towards the top of the calculator. We have the N button, the I/Y button, the PV button, or the present value, the PMT button, or the payment button, and the FV button, or the future value button. Now for this problem, we're not going to be using the payment button. We'll come back to that when we talk about annuities, but the rest of these buttons are going to be very helpful for calculating the present value or the future value for a specific scenario. Now this N button right here, that is exactly what you think it is. That is going to be the value of time periods. In this case, N is equal to 5, so we're going to be plugging 5 in for that. And then this I/Y button, that is your interest rate. You want to make sure that whatever that interest rate is that you're going to be plugging in occurs at the same frequency as your time period, right? So if my value of N in my calculator is going to be measured in years, like it is right here, then I want to make sure that the interest rate that I put in for I/Y is a yearly rate. All right, and so in this case, that interest rate would be 4%. Okay, and so our initial deposit of $600, that is going to act as our present value, right? That is the amount deposited today that we want to know the future value of in 5 years. And so something that you will have to get used to when you use a financial calculator is that when you put in a value for your present value, you're going to have to put a negative sign in front of that initial deposit or that present value in order to ensure that your future value calculation is correct. And I'll show you that it's not a huge deal if you forget it. Your future value will just be negative instead, and so you'll have to remember to make that positive when you write down your final answer. And so in order to calculate this future value, we'll start by putting in our initial deposit, and so that's going to be negative 600, and so I'll type in 600, and then we're going to make it negative. And what we're going to do is after we type that value in, press the present value button. So we press that, and now the present value is equal to negative 600. Okay, so that's good. You kind of have to do it in reverse order. You don't press the present value button first, you put in your value first and then press the present value button. And the same process applies to the rest of these white buttons as well. All right, so then let's put in our value of N. We know that that is equal to 5, and so we put in 5 and then hit the N button. And so now N is equal to 5. And then our interest rate is 4%. And so be careful here. Your calculator is going to work in percentages, not decimals, at least when it comes to the I/Y button. And so in this case, we're not going to be plugging in 0.04. We're going to be using that 4% instead. And so I'll hit 4 and then I/Y, and that is our interest rate. And now the next thing we want to do is compute the future value. So we're going to hit the compute button, which is in the upper left-hand corner. And so we'll press that, and then we'll hit the future value button because that's what we want to compute. And so now you'll see that we get the same answer right here that we get when we solve this problem by hand, and that is that the future value is $729.99. All right, and so if you're following along and for some reason you got the wrong answer, if your answer does not look like this, either you typed in something wrong or there was a value in your calculator that was not cleared. And so what you want to do is make sure that if you clear your work and you'd hit second clear work, and you hit all these buttons, you want to make sure that they all say 0, right? Your N should be 0, your I/Y should be 0, present value should be 0, the payment should be 0, and the future value should be 0 before you plug in any of your values for this problem. All right, so make sure that those are cleared out, otherwise you might get the wrong answer when you go to solve for the future value. Okay, but if we clear the work here, let me show you what would happen if we didn't make that 600 negative. And so if I type in 600 and keep it positive and make that the present value, and then we set 5 equal to n and 4 equal to the interest rate, and then we compute the future value, you'll see that we have the same answer, but now it's negative. And so if you can't remember to make your present value negative, just know that your future value will be negative, but that's not the actual future value. Your future value would be positive $729, not negative. Okay, and so I want to show you one more thing with regards to a future value problem. And so what I'm going to do here is I'm going to store this value in the 0 button, and then I'm going to clear my work here. And so what we can do is, let's say that instead of solving for the future value in this problem, let's say that we had the future value, but we didn't know what the interest rate was, right? So what we could do is recall that value that I stored in 0. We will make that the future value. We'll make 600 our present value. Now I didn't make it negative there because that stored value I had was a negative future value. So I want to make sure that the present value is positive to keep everything in check. And then we'll set 5 equal to n. And now we can compute the interest rate. So if I press that, it will give us back 4. Okay, so you don't have to just compute the future value. You can also compute n, the interest rate, or the payment amount for a particular scenario, given that you have all of the other values. All right, so that's just something to keep in mind. All right, so now we're going to be talking about how to calculate the present value for a specific scenario using this calculator, and it's actually very similar to calculating the future value. And so if you didn't watch that section, I would recommend that you go back and watch how we calculated the future value, because that directly ties in with calculating the present value in this problem. All right, so we're going to be using the same row of buttons, these white buttons right here. And so as an example of calculating the present value, we're going to be looking at this problem, which is from one of my examples videos on my main channel, so you can check that out if you'd like. But here's how we solved this problem by hand. We found that the present value for this scenario was $3,756.57. And that was given that Jeff wants to accumulate $5,000 in order to make a payment in 3 years. If he makes a deposit into an account today that earns 10% effective annual interest, how much should his deposit be? Right, so that is a present value problem. We want to know how much he deposits today, the present value of an amount $5,000 that he will have in 3 years. All right, so we're told that the interest rate is 10%, the number of years n is 3, and the future value is 5,000. And so what we'll do is we'll type in that 5,000. We're going to make it negative, and then we'll press the future value button. Then we will hit 3, and then we will hit the n button. That is the number of years. And then we will type in 10 and make that the interest rate. And then we will hit the compute button and then hit the present value button, because that is what we want to compute. And as you can see, we got $3,756.57, which is exactly what we got when we solved this problem by hand. Okay, so calculating the present value is very similar to calculating the future value. All right, next up, we're going to be talking about how to work with cash flows in your calculator. Specifically, how do we find the future value or present value of a series of cash flows using the cash flow function of the calculator. And so a new button that I'm going to introduce you to here is this capital C, capital F button, which stands for cash flows. And if we press that button, we'll be taken to the cash flows menu, and it should look like mine here if you have never used it before, meaning there's no values in it. And what you're looking at here is the initial deposit, or the first cash flow at time 0 for a particular scenario. Now, before we type anything in, let's look at our example here. This is another example that I pulled from one of my own videos. And in the example, we are told that Sarah deposits $1,000 today, $1,000 in 2 years, and in 6 years from today, she withdraws $500. And we want to know how much is in her account at the end of 8 years if her yearly interest rate is 1%. And so here's the timeline of our cash flows. We have that initial deposit of $1,000, another deposit in 2 years of $1,000, and then that withdrawal of $500 at year 6. And then we don't know what the value is at t equals 8. And so then we have the work here that shows how you would calculate that future value by hand without using the cash flows function on the calculator. But I'm going to show you how you can get this same answer by only using the calculator. All right, but to go back to our calculator, you want to make sure that all your work is cleared first. So once you're in this cash flows menu, be sure to hit second and then clear work. Most likely you don't have anything in there if this is your first time using the function, but just to be sure, make sure to clear that work out. And then what you're going to do is you're going to type in your value for your first cash flow, right? The cash flow at time 0. And so in our case, that cash flow is 1,000. So we will type in 1,000. And then after you're done typing in your number, you will hit the enter button to enter it in for that cash flow. Now, from here on out, you're going to be using these arrow buttons to navigate to other cash flows. And so we're going to hit this down button to get to our cash flow at time 1. All right, now in our problem here, we actually don't have a cash flow at time 1, right? Our next cash flow is at time 2, and so we're going to keep this cash flow in our calculator here as 0, right? It's currently 0, but I'm just going to plug in 0 again just to be sure. So I hit 0, and it'll hit enter, and then we will hit this down arrow, and now we have F01, and what that means is the frequency of that cash flow. Now, that cash flow at time 1 only occurs one time, and so it's currently set at 1, and so we don't actually need to change anything. And so I will hit enter, and then we will move on to our next cash flow, which is cash flow at time 2. Okay, and so our cash flow at time 2 is another deposit of $1,000. And so once again, I'll type in 1,000 and hit enter, and then I'll hit the down arrow. The frequency of that cash flow is just 1. And so I don't need to change anything there. I can hit enter if I'd like to, but I don't have to. So I'll hit the down arrow. And now we are on our third cash flow. And so now we're going to repeat this process for all the cash flows in our problem, which we only actually have one more. And that is at time 6, where we have a withdrawal of $500. And so we actually don't want to type anything into our calculator here until we see C06, right? The 6th time period where we have that next cash flow. All right, so that's good. So we're just going to hit enter to make sure that cash flow 3 is equal to 0. And then we'll go down. The frequency of that is just 1. So then we'll go down to C04, and that is still 0. So we'll hit enter, and then we'll go down, and the frequency is still 1. So we're good. We go down to C05, and that's also equal to 0. So we'll hit enter, and then go down to the frequency, which is still 1. And then we'll go down to C06. This is what we've been looking for. We can now type in our withdrawal of $500. So I'll type in 500, but make sure to make that negative because it is a withdrawal. And then we'll hit enter, and then we'll go down. F06 is 1, so that's good, right? That is the frequency. It only occurs once, right? We're only making one withdrawal of $500, and so that's it. So now we are done. That is the last cash flow that we know about in our problem. And so now what we will do is we will hit the NPV button, and that is this button right here. That stands for net present value. So now, although we want to calculate the future value in our example, we first have to calculate the present value in our calculator. All right, so I'm going to hit this NPV button, and now what it gives us is it says I equals. It's asking us for an interest rate. And so our interest rate in this case is 1%. And so I'm just going to put in 1 and then hit enter. And now we have our interest rate. And then what you can do is hit this down arrow, and it will take you to NPV, which is the net present value. And so if you hit the compute button, it will compute that present value. Okay, so that's the present value for this scenario. Now don't be alarmed, that does not match our future value number here, And it shouldn't because it's not a future value, right? Your answer is not incorrect. So what we're going to do with this value for the present value here is we're going to store it in our calculator and then use it for a future value scenario. And so what we can do is if we hit this clear button, it's going to get rid of that MPV menu stuff. So now you notice we just have that value. We can set that equal to the present value for a particular scenario. And then we want to know the future value of that present value in 8 years, right? We currently have the value at time 0, and we want to know the value at time equals 8. And so we're going to hit 8 and make that n. And then our interest rate is still 1%. So I'll hit 1 and then I/Y. And then we can hit compute future value. And lo and behold, there is our future value. Now it's negative because I forgot to make our present value negative, but just remember that this would be a positive future value. And so we have the same answer of $1,634.33, which we had when we did it by hand. All right, and so that is how you use the cash flows function on the BA2 Plus calculator. All right, so next I'm going to show you how to convert interest rates on this financial calculator. And so what you want to do to convert interest rates is you want to hit the second button and then the to button, which has the letters ICONV above it. That function is the interest conversion function. That's what the ICONV means, interest conversion. And so if we do that on our calculator here, if we hit second and then the to button, we are brought to this menu where it says NOM, that stands for nominal interest rate. And then if we hit the down arrow, we have EFF for effective interest rate. And then if we hit down again, we have C/Y, and that is telling us how many times per year the nominal rate is convertible. And so this one might already have a value in it. That's okay. We can overwrite that when we start converting interest rates. And so I'm just going to hit this down arrow again to get back to the nominal rate because that's where the menu starts when you open it. And so for our example here, I have a problem that I took from one of my lesson videos. Again, link for those are in the description. And here we have a nominal annual interest rate of 10% convertible semi-annually, and we want to know the effective semi-annual interest rate and the effective annual interest rate. Okay, so I'm going to show you how to get both of these rates, and here's how you would find them by hand, but let's start by just plugging in what we know into our calculator. So we know we have a nominal annual interest rate of 10% convertible semi-annually. So in our calculator, we have nominal, so I'm going to plug in 10 and hit enter. That is our nominal rate. And then if we hit the up arrow here, we'll be at the C/Y, and it already has 2 in here. Now we're actually not going to have to change that because this nominal rate is convertible semi-annually or 2 times per year. And so this is good. It's already set at 2. All right. And then we'll hit the up arrow again. And now we're at EFF, or the effective annual rate. And so if we hit the compute button here, it will compute that annual effective rate. You can see that we have 10.25, which is 10.25%, which is the same as this interest rate right here of 0.1025, right? So that's how we would take this nominal rate, plug it into our calculator, and calculate the equivalent effective annual rate. Now, if we wanted to calculate the effective semi-annual rate, we really don't need to use a special function in our calculator for that, since we would just take that nominal rate of 10% and divide it by 2, right? Since that nominal rate is convertible semi-annually, if we divide that by the amount of times it is convertible per year, that will give us that effective interest rate, right? This rate is convertible semi-annually, so dividing it by 2 will give you the effective semi-annual rate, which is this 0.05 right here. So you could just put in 10 divided by 2 in your calculator, and you would get that 5%. All right, but for a second example here, what is the equivalent monthly effective interest rate if the annual effective interest rate is 6%? So this time we're going to be working the other way around. All right, so if we go to our calculator here, I'm going to hit second clear work, and now we're back to 0 for our nominal rate. Everything has been reset. And in this case, we don't know what the nominal rate is, but we're going to be able to use that to find the equivalent monthly effective interest rate, right? We know the annual effective interest rate is 6%. And so if we hit the down arrow to go to EFF, that is the effective rate, we can put in that 6% and hit enter. And we want an equivalent monthly effective interest rate. So if we go down to C/Y, there are 12 months in a year. So I'll put in 12 and hit enter. right? So that interest rate will be compounded 12 times per year. And then if we hit the down arrow again, we have our nominal rate that we will compute. Now, that's not what this problem is asking for. It's not asking for the nominal rate. However, it is asking for an equivalent monthly effective interest rate that we can find from the nominal rate. So that nominal rate that we just calculated is going to be pretty helpful here, right? Because this nominal rate here, assuming we typed in the right numbers, should be a nominal rate that is convertible monthly, 12 times per year. And so if we clear out of this menu, we can divide that value by 12, and that will give us the effective interest rate that is monthly, right? And so you'll see that we have 0.4867, which would be a percentage that lines up with this decimal value right here. Remember, your calculator works in percentages and not the equivalent decimal value. So if you wanted to know the actual decimal value, you would have to divide that value by 100, and then you can see that that is the same as what we got in our example problem by hand. Okay, so that's two different ways that you can use that interest conversion function. You can either start with an effective rate and get a nominal rate, or you can start with a nominal rate and get an effective rate. And you can use those different rates to find some other rates as well, such as effective rates that aren't annual. All right, so that's all you need to know about converting interest rates. All right, so now we're going to talk about how to find the future value or the present value of an annuity-immediate. And so this is typically the first type of annuity that you will learn about, as opposed to an annuity-due, which we will look at in the next section. But here we have an example from one of my videos about annuity-immediates, where Fred is investing $300 per year for a total of 20 years into an account that has an annual effective interest rate of 7%, and we want to know how much does Fred have after the last $300 is invested, right? So we want to know the future value for payments of $300 for 20 years with an interest rate of 7%. Okay, so just like when we calculated a basic present value or a basic future value, we're going to be using this row of white buttons on our calculator, except this time we're also going to be using this payment button that we didn't use previously. Remember, I said that we would come back to that later on. Well, now we're here and we're going to use that button. And so that's actually the first thing we're going to type in here. We know that Fred's payments are $300 each, so I'll type in 300, and then we'll hit the payment button. That is what our payments are equal to. And then we know that he's going to be making 20 of those, so we're going to type in 20 and then hit N. And then our interest rate is 7%, so we'll hit 7 and then I/Y for interest rate. And then we will hit the compute button and then the future value button, because that is what we want to compute. And you'll see that we get $12,298.64, which would be rounded up to 65 cents, and that would match this answer right here that we got when we did this problem by hand using that notation or that formula for an annuity-immediate. However, do note that it is negative here, and that's just because I didn't make my payments negative. If you would have made your payments negative, if you would have had negative 300 as your payment, then the future value would have came out positive, but it just seems like a little bit of an extra step that we can kind of ignore. Since we know that the future value is going to be positive anyway, we can just ignore that negative sign and know that we have the correct answer. All right, but let's look at a present value problem now. And so here's our present value example. Again, this is taken from one of my videos that you can find on the channel. And in this example, we have that Daniel wants to make a deposit into an account today so that he can withdraw $200 each year for 15 years, with the first withdrawal taking place 1 year from now. If the effective annual interest rate is 4%, how much should he deposit? All right, so that is looking for a present value because we're looking at how much Daniel needs to deposit today. And we know that the payment amount will be $200 because he wants to withdraw $200 each year for 15 years. And so then N is equal to 15. That is the number of payment periods. And then the interest rate is 4%, which we are told right here. And it is an annual interest rate. And so that matches the frequency of the payment cycle. And so we're good. And so now all we have to do is punch those numbers into our calculator and calculate the present value. And so what we'll do is we'll clear our work from our previous example. And then we'll type in our amount of the payment, which is 200, and then I'll hit the payment button, and then we'll type in 15, that is our value of N, and then 4 is our interest rate, and then we will hit the compute button and compute the present value. And that will give us the present value of $2,223.64. $2.68, which is what we found over here. But once again, you will see that it is negative, just like our future value was, but you can ignore that. That is going to be the correct answer for this example. All right, so next up, we're going to be talking about how to calculate the future value and present value of an annuity due by using this financial calculator. And if you remember, the difference between an annuity-immediate and an annuity-due is that the payments in an annuity-immediate are made at the end of every payment period, but in an annuity-due, the payments are made at the beginning of the payment period. And so what you have to do before you can calculate anything regarding an annuity due is to set your calculator to begin mode, meaning that the payments are set at the beginning of the payment period. And so what you're going to do is you're going to hit the second button, which is right here. So we'll hit second, and then you're going to hit the payment button, which above it has the letters BGN. Now BGN, I assume, is just short for beginning. So if we press that, it says end. And so what that means is that currently, if we were to calculate an annuity, it is assumed that the payments are being made at the end of a payment period. However, if we hit the second button again, and then we hit the enter button where it says set above it, that is going to change that to the beginning, right? BGN means beginning, and so now it is assuming that when we calculate an annuity, that the payments are made at the beginning of the period, not the end. All right, so now that we've done that, we can hit second and then compute, which will quit out, right? When we hit second, we're going to be using the quit function. And so we'll hit second quit. And now we're back to our main screen where we just have a bunch of zeros. But now you'll notice that above the zeros, we have that BGN, which lets you know that your annuity calculations are going to be for an annuity due, where the payments are at the beginning of the period. Now, let's say you want to switch that back real quick. I'm going to show you how to switch it back. It's real simple. You would go through that same process. So you would hit second payment, and then you would hit second enter, and now that BGN was gone. So now we're back to the end, and now you would be good for an annuity immediate. But we don't want to do that for this example. So let's go back. Let's hit second enter again. We're back to beginning, and then second quit, and now we're ready to compute an annuity due, right? And so the rest of it is pretty simple. It's the same as calculating an annuity immediate. All we had to do beforehand was press those couple buttons to set it to the beginning of the payment period. All right, so here I have an example from one of my videos, once again, where we calculated the present value and the future value for an annuity due. And so I'll just show you real quickly how we would calculate this so that you can see that it works. In this scenario, our payments are equal to 60. We have 10 of those payments, and the interest rate is 5%. And so we'll type in our payment amount of 60. That is the payment. And then n is equal to 10. And our interest rate is 5%. All right, so let's start by calculating the present value. So I'll hit compute present value, and there is our $486.47 that we have right here. And then if we want to calculate the future value, we'll go through all of that again, but instead we will compute the future value instead of the present value. And so I'm going to hit second clear work, and then we'll clear everything there. And then we'll plug in all our values again. And so we'll have 60 as our payment, 10 as our value of n, and 5 as our interest rate. And then we'll hit compute future value, and that will give us $792.41 if we round, and that will match up with our future value right here when we calculated that by hand in one of my other videos. Okay, so that's how you would calculate the future value or present value of an annuity due. All right, and then when you're done calculating an annuity due, I always recommend that you set your begin mode back to end so that you are less likely to make some mistakes later on when you go to calculate an annuity immediate and you forgot that your calculator was in begin mode. So just clear your work and hit second payment, and then second enter, and then second quit. And now your calculator is back to the end of each payment period when calculating annuities. All right, so next up, we're going to be looking at how to calculate continuous annuities on the calculator. Now, this isn't anything special. In fact, it's already using functions we know how to use. I'm just showing you a little trick for when you have a continuous annuity. Because if you recall, here are our formulas for calculating a continuous annuity. They're not very common, but their formulas are very similar to an annuity-immediate, except the denominator has a force of interest instead of a regular interest rate. And so because of that, we said that we could rewrite these formulas to be the notation or the formula for a regular annuity-immediate times the interest rate divided by the force of interest. And so that's kind of the trick that I want to make you aware of here, that if you have a continuous annuity, you can just calculate the annuity-immediate and then multiply it by the interest rate divided by the force of interest. And of course, that works for a future value scenario or a present value scenario. And just remember that the force of interest is equal to the natural log of 1 plus I. And so just real quick, let's look at an example here. And once again, I took this problem from one of my other videos. And in this particular scenario, we have an annuity that pays $100 continuously throughout 12 years. And it has an annual effective interest rate of 7%. And so our payment amount is 100, our amount of periods is 12, and our interest rate is 7%. And so let's start with the present value here. And so we'll type in 100 as our payment, and then 12 is our value of N, and then 7 as our interest rate, and then we will compute the present value. Now, this present value is not the actual present value of our continuous annuity, right? This is just a calculation of our annuity-immediate with those same values, but we need to multiply it by the interest rate divided by the force of interest. And so let's save this present value in our calculator, and then we'll bring it back out when we're ready to multiply it by the interest rate divided by the force of interest. And so let's hit store, and I'm going to store that in the 1 button, so that'll be right there. And then let's clear our work. And then let's work on dividing the interest rate by the force of interest, and then we will multiply that by that present value that we stored. All right, and so the force of interest is equal to the natural log of 1 plus the interest rate. And so in this case, our interest rate is 7% or 0.07. So we will have 1.07, right? That would be 1 plus the interest rate. And then we will hit this natural log button to take the natural log of it. Okay, so that's our force of interest. But now we want to divide our interest rate by that force of interest. And so I'm going to show you a little trick here. Rather than save this value and then recall it in order to divide 0.07 by it, what I'm going to do is divide this force of interest by the interest rate, 0.07, and then hit the reciprocal button, and that will flip it so that it will be correct. Right, so instead of having the interest rate divided by the force of interest, we're going to do it the other way around. We're going to have the force of interest divided by the interest rate, and then hit the reciprocal button, which will flip the numerator and denominator, and so we will have the interest rate divided by the force of interest. I hope that makes sense. So if we divide this force of interest by 0.07 and hit equals, and then we use the reciprocal button on this value, I'll press that, we now have I divided by the force of interest. Okay, so then let's store that in the 2 button just so we don't lose that, but we're going to multiply this by our present value that we stored earlier. And so let's hit the multiply button and then recall 1, that's where we stored it, and let's just make it positive, so hit the plus or minus button and then hit equals, and there is our $821.75, which matches up with our present value right here. All right, and so let's go through that process again, except this time let's do it for the future value. And I'm going to go through it a little bit quicker here so you can see how this would be done in real time. So let's clear our work and then hit second clear. Okay, so once again, our payments are $100. So we'll hit payment, 100, 12 is our value of N, and our interest rate is 7%. Then we will hit compute, future value. That is the future value of a regular annuity-immediate, not the continuous annuity. And so we're going to store that value. I'm going to put it in the 4 button, and then we will clear that. And then I'm going to recall our value in the 2 button. Remember, this was our stored value for I divided by delta. And so we can multiply that by our future value. And so I'll hit multiply and then recall 4. And then once again, let's make that positive. And then let's hit enter. And there is our future value of $1,850.75. And so that matches up with our answer when we did that manually by hand. All right, so that's how you would calculate continuous annuities using a financial calculator, or this one specifically, the BA2+. All right, so next up, we're going to talk about how to calculate geometric annuities in our financial calculator. And when we talk about geometric annuities, I'm assuming that you are already familiar with the concept of a geometric annuity. And so if you're not, be sure to watch my video on that first, And if you do that, the rest of this will make a lot more sense, because here are my two examples from my lesson video on geometric annuities, as well as their calculations. This was the present value of a geometric annuity, and this is the future value of that same geometric annuity. And so if you remember, when calculating a geometric annuity, I gave you this 4-step process, and I'll have it up here on the screen on how you would calculate them. You would value each payment at the valuation date, and then you would pull out that first term, and then the rest of your terms could be rewritten as a geometric series, which we then knew how to calculate the sum of. And I have the result of our calculations from that video right here, as I already mentioned. And this part right here, this 50 times the present value factor, and this part right here, 50 times the accumulation factor to the power of 9, those are the first terms that were pulled out of those series of payments when valued at the valuation date. What's left over here, as you'll notice, is actually the same expression, right? 1 minus this quantity to the 10th power divided by 1 minus that quantity, and then that exact same expression is down here. Okay, and not only are these two expressions the exact same, they can actually be recognized as an annuity-due. And so let me show you what I mean. Once again, here's our two calculations. We can represent this expression as the present value of an annuity-due, right? Because this is the notation for the present value of an annuity-due, and it's equal to this expression right here, which is very similar to this expression and this expression if we set the present value factor, which is equal to 1 divided by 1 plus I, equal to that 1.05 divided by 1.07, right? And so what we can do is calculate the present value and future value of this geometric annuity by multiplying that first term by the present value of an annuity due, where the interest rate is calculated from this expression right here, 1.05 divided by 1.07. And remember that this is just a ratio of the inflation rate to the interest rate, right? And so instead of using that 4-step process from earlier, we can instead use this 3-step process along with our calculator and make calculating geometric annuities a lot easier. We're still going to value each payment at the valuation date, and then we will factor out the first term, which would still be these two factors right here, and then recognize the remaining factor as the present value of an annuity due using that interest rate K, where K is found using the ratio of the inflation rate to the interest rate. And this is what that would look like, which if you solve for K, gives you this expression. And so if you take 1 plus your interest rate divided by 1 plus the inflation rate minus 1, then you have your value of K that you can use for that annuity due. And so let's test out that theory. Let's see if we can find the same present value and future value for this geometric annuity using this 3-step process. Now, we already have the first and second steps done for us. Again, if you want to see those in action, check out my lesson video for geometric annuities. But let's just focus on this third step and then finally finding the future value and present value. So let's start by calculating K. In this case, our interest rate is 7% and our inflation rate is 5%. That just means that each of our payments was increasing by 5%, by the way. That's what the inflation rate means. In a geometric annuity, your payments increase by a certain percentage known as the inflation rate, which is 5% in this case. All right, so let's take 1.07, which would be 1 plus I, and divide it by 1.05, which would be 1 plus R. So we'll have 1.07 divided by 1.05, and I'll hit equals. And then if we subtract 1 and hit equals, that is our value of K. Now we're going to use that as our interest rate for our annuity due calculation. However, this is in decimal form. It's not in the percentage form that we need to use in our calculator. So if you multiply that decimal by 100 and hit equals, we now have a 1.9% interest rate that we will use for that annuity due calculation. Now, just so I don't lose this value, I am going to store it in my 3 button here in case I need to recall it or I make a mistake later on. But before we can calculate the annuity, we need to set our calculator to begin mode so that we can calculate an annuity due and not an annuity immediate. So we'll hit second and then payment, which is where begin is. And then we have end currently set. And so if we hit second, enter, then that will change to begin. Then we can hit second, quit. And now we're ready to calculate our annuity due. And so I'm going to recall and then hit the 3 button, which is where I stored our interest rate K. And we're going to make that the interest rate, so I/Y. And for this geometric annuity, the number of payment periods is 10. And so I will put in 10, make that equal to n. And then since we have this same notation for the future value and the present value, it's just multiplied by a different payment amount. I'm going to ignore those payment amounts and just use a payment value of 1 and then multiply these factors by that notation to get the actual value. And so I'll show you what I mean. Let's just make the payment value 1, and then let's compute the present value of that annuity due. And you'll see that it says it's $9.19, or I guess you could say it's $9.20. Let's just make that positive, and then let's store that in the 6 button, because we're going to use that to calculate our present value and future value for each of these scenarios. In fact, let's go back to our example problem so that you can see the answers. We just calculated this expression right here for each of these examples. And so let's multiply it by 50 times V. Remember that V is 1 divided by 1 plus the interest rate, which is 7%. So we will have 1 divided by 1.07, and we'll hit equals. That is our present value factor. And then we'll multiply that by 50 and hit equals. And then we'll multiply that by that present value of an annuity due that we calculated. And so let's hit recall 6. There's that present value we calculated, and then we'll hit equals. And now we have our answer of $429.88, which we have right here. Now, if we instead wanted to calculate the future value, we can clear our work here, and we'll take 50 times 1.07 to the 9th power and multiply it by that present value of an annuity due that we calculated earlier, right? So we'll take 1.07, and then we'll hit the power button, and then the 9 button, and that will take that 1.07 to the 9th power. So let's hit equals, and then we will multiply that by 50, hit equals, and then we'll multiply that by that present value that we calculated. So I'll recall 6, and then hit enter, and there is our $845.64, which we had right here. Okay, so that is the trick to calculating geometric annuities. You just have to remember this new 3-step process for when you use a calculator rather than that 4-step process that you used when doing it by hand. All right, and so now that we're done, I'll clear our work, and then I'm going to set the payment period back to end, and then quit that menu, and we're ready to move on to our next function of our financial calculator. All right, so next up, I'm going to show you how to calculate arithmetic increasing annuities on your financial calculator. And so if you recall, this table is from one of my videos. These are the 4 formulas for arithmetic increasing annuities, whether you're calculating the present value or future value of an annuity-immediate or an annuity-due, where the payments form an arithmetic increasing progression. These formulas are how you would calculate each of those values. However, there's not going to be a very nice button in your calculator that allows you to calculate an arithmetic increasing annuity quickly. What we're going to have to do instead is a little trick. It's really not that complex of a trick. Is just notice that in each of these expressions that there is a calculation for the present value of an annuity due or the future value of an annuity due, depending on the formula. And so what you can do is calculate that annuity due and then subtract the other part in the numerator and then divide by the interest rate. And that will allow you to calculate that annuity in your financial calculator. And so let's take a look at an example. This is an example from one of my videos where we're looking at the future value of an arithmetic increasing annuity. And it says Samuel starts to make annual deposits with an initial deposit 1 year from today of $7. And then he increases the amount of each subsequent payment by $7 until he reaches his final payment of $77. What is the future value of Samuel's payments if the account he makes the deposits in pays an annual effective interest rate of 5%? Now, this is the work for that calculation that I did in one of my other videos. But what we're going to do is calculate this in our calculator by taking this expression right here and breaking it up into smaller parts. We're going to calculate this future value of an annuity due and then subtract 11, divide by 0.05, and multiply by 7. All right, and so let's calculate this. Let's go to our calculator here. Now remember, we're working with an annuity due, and so we need to make sure that our calculator is set to begin mode. So I'm going to hit second and then payment, and currently it is set to end, but if we hit second and then enter, that will set it to begin mode, and so we can hit second, quit, and now you can see that our calculator is in begin mode. All right, so for this future value of an annuity due, note that there is nothing being multiplied in front of it. Don't use that 7. Multiply that in later. So we're just going to say that this has a payment of $1. All right, so our payment is $1. We'll hit the payment button. Then our interest rate is 5%, and our value of n is 11. So I'll make that n. And then we will compute the future value, right? That's what this S right here is for. That means future value rather than an A, which means present value. All right, so then there's our future value. You see it's 14.9 and then some more decimals. Let's make that positive by hitting that plus or minus button. And now we can subtract 11 from that value. And so let's do that. We'll hit subtract 11, hit enter. And then we can divide that by 0.05. So I'll hit divide 0.05, hit enter, or equals, I guess. That's the equals button. The enter button is up there. I meant to say equals, hit the equals button, and then we will multiply that by 7. So I'll hit times 7 and hit equals, and then we have 548.397, which rounds up to 548.40, which matches up with our example right here. Okay, and so this was just one example of an arithmetic increasing annuity, but this would apply to all different types where you would be calculating the present value, or your actual arithmetic increasing annuity would be an annuity-due, not an annuity-immediate, like this one was, right? This was an actual annuity-immediate that had an increasing arithmetic progression, but that formula included an annuity-due expression, and so that's why we used annuity-due in our calculator. It can be a little bit confusing, but remember, just reference back to that chart that I had on the previous slide, and that will make sure that you're using the right formula. Okay, so let's clear our work, and then we'll move on to our next topic. All right, so next we're going to talk about how to calculate an arithmetic decreasing annuity in our calculator. And this is very similar to how we calculated an arithmetic increasing annuity, except the formulas are slightly different. And so in this case, recall that these are the formulas for an arithmetic decreasing annuity, whether it's the present value or future value, or it's an annuity-immediate or an annuity-due. Right? These are the formulas that we would use to calculate that arithmetic decreasing annuity. And again, I pulled these from one of my own videos where I talk about these types of annuities and how to calculate them. And so if that interests you, remember that all of my videos can be found in a playlist that is linked in the description below. Okay, but notice that in each of these expressions or these formulas, just like with an arithmetic increasing annuity, there is an annuity calculation within those formulas, right? So in this formula right here, we have n minus the present value of an annuity immediate, or if you look at this formula here, we have n times 1 plus I to the power of n minus the future value of an annuity immediate, and then those expressions are also found in these two formulas. And so what we can do is calculate those annuities and then subtract them from the previous term, divide by I or whatever else is in the denominator, and then multiply by whatever is on the outside. So it's a very similar process to what we did in the previous section for arithmetic increasing annuities. It's just different formulas that we have to work with. And so let's look at an example. This time we are calculating the present value of an arithmetic decreasing annuity, but let's read the problem. We have that a 10-year annuity immediate has a first payment of $2,000 and decreases by $200 each year thereafter. Assuming an effective annual interest rate of 6%, calculate the present value. All right, and so here's the calculation and solution to this problem. Of course, this comes from one of my other videos where I talked about how to solve this, but this video is just about how to calculate it in the calculator. And so it's going to start by calculating this right here, which is the present value of an annuity immediate. So now if you look at our calculator, it's currently set to begin mode. So you want to make sure that since we're calculating an annuity immediate, that is set to end, not beginning. So if you see that begin up there, BGN, you want to get rid of that. So what we're going to do is we're going to hit the second button, then the payment button, and then we see that it says begin. So we'll hit second and then enter or set, and then that will change to end. And so we can hit second compute or quit, and that will take us out of that menu. Okay, so then let's start. The payment amount for this annuity immediate will be $1, right? Nothing is being multiplied by that expression. So the payment amount is 1. So we'll make that the payment. And then our interest rate is 6% and our value of n is 10. And so we'll have 6 as the interest rate and then 10 as our value of n. And then let's compute the present value, right? That's what that A represents, the present value of the annuity immediate, not the future value. All right, but there's our present value of 7.36. Now let's make that positive, and then what we're going to do is we're going to store that value in one of our buttons. So I'm going to put it in the 9 button. And then note that we're going to have to subtract that expression from 10. And so that's why I stored the value, because now what we can do is clear that, and we'll take 10 and we will subtract that amount. So we'll hit recall 9, hit enter, and now we have that result. And so now we have calculated this part. So let's divide by 0.06. So we'll have divide 0.06, hit equals, and now we have 43.99, and now we can multiply that by 200, and that should give us our present value. And so we'll hit the multiply button, and then type in 200, hit equals, and there is our present value of $8,799.71, which matches up with our present value right here when we calculated it by hand. Okay, and so that's how you would calculate an arithmetic decreasing annuity using your financial calculator. All you have to do is break up your formulas for arithmetic decreasing annuities into several smaller calculations that your calculator can handle. All right, and so with that, let's clear our work and move on to our next topic. All right, so next up, we're going to talk about how to do the amortization method in the financial calculator. And typically this is useful for loan repayment problems that use the amortization method. And so here I have a completed amortization schedule from one of my examples in one of my videos on amortization. And so here you can see that the original loan amount, or the outstanding balance in time zero, was $950. And then we have the principal paid, the interest accumulated, and the outstanding balance for the rest of the 4 years for this specific scenario. And in this example, our interest rate is 6% or 0.06, and the payment amount is $274.16. All right, so now this is actually one of my favorite functions of this calculator. It makes the amortization method a breeze, especially if you're just trying to quickly check your work after you did it all by hand. All right, so at the beginning here, it's going to look like we're just going to be calculating an annuity in our calculator, but we're actually setting it up so that we can use the amortization function in our calculator. So in this case, our present value is going to be $950, right? Remember that the initial balance or amount of the loan that needs to be repaid is the present value for that scenario. So in this case, our outstanding balance at time zero, like I said, is $950. And so let's put in 950, make that our present value. And our interest rate is 6%, so that'll make that our interest rate. And then our payment amount is $274.16. Now, in this case, I would recommend that you make your payment amount negative. That will help out with the amortization schedule to make sure that it is without errors. And so I'll type in 274.16, and I'll make that negative by pressing the plus or minus button, and then I'll hit the payment button right there. And then we don't need any value for n. The calculator actually doesn't need to know that, and you'll see why in just a second. But now we are done, and instead of calculating or computing the present value or future value, we are going to hit the second button and then the present value button. Because above the present value button are the letters AMORT, which is short for amortization, which is where the amortization function for your calculator can be found. So we'll hit second and then the present value button. And now we get this menu where it says P1 equals 1. Now, if you hit the down arrow, it'll say P2 equals 1. What P1 and P2 mean are the beginning period and the end period. So now in this case, since both values are 1, right, P1 is 1 and P2 is 1, that means that we're just looking at the first year for our amortization schedule. So if I hit the down arrow again, here is our balance at year 1. You'll see it says $732.84, which is exactly what we have right here in our amortization schedule. If we hit the down arrow again, it will give us the principal paid in that period. Now it's negative, but it's actually a positive amount that is paid. But it says $217.16, which is what we have right here. And then if we hit the down arrow again, we have negative 57, which means the interest paid is $57, which we have right here in our table. So it got all those values right. This whole row for year 1 is in our calculator using that amortization function. Now, if we hit the down arrow again, it will take us back to P1. So now what we can do is hit 2, and then enter, and now P1 is equal to 2, and if we hit down again, we can change P2 to 2 as well. So I'll hit 2, and then enter, and then we'll go down, and now we'll have a balance that is different. This time it's $502.65, which matches up with our balance in year 2 in our amortization schedule. So we'll go down again. There's the principal repaid of $230.19. That matches up with our table. And then I'll go down again to our interest of $43.97, which also matches up with our amortization schedule. All right, so you can kind of see how this works. I'll hit the down arrow again, and now we'll set P1 equal to 3. And we'll do the same thing for P2. I'll hit 3, enter, and now we'll get the same values for year 3. The balance is $258.65. Then we'll go down to the principal, which is $244, and the interest, which is $30.16. All right, so then we'll go down again, and we'll set P1 equal to 4. So we'll hit 4 and enter. We'll set P2 equal to 4 and hit enter. And then now the balance is basically $0. It says 0.0083, but that's basically 0, which matches up with our amortization schedule. And then if we go down again, you'll see that the principal is $258.64. And then if we go down again, we have our interest of $15.52. All right, and so if we go back down, that is how you use the amortization function to fill in an amortization schedule. And so it was pretty simple. We just put in our values of the payment, the original outstanding balance, and our interest rate, and then we could fill in this whole table just by hitting some up and down buttons, as well as changing the periods of time with that P1 and that P2. All right, and then just one more thing that I want to show you is that if we set P1 to 1, so if I hit 1, enter, and keep P2 as 4, which is the total amount of periods, right? For this amortization schedule, we're looking at 4 periods, and then we go down, it will tell us the balance at the end of that 4th year, which is still 0. And if we go down, it will tell us the total amount of principal paid. That's pretty cool. And if we go down, it will give us the total amount of interest paid. And that's also pretty cool. And so if you set P1 equal to 1 and P2 equal to the value of your final period, you can find out the total amounts of the interest and the principal paid for your scenario. Okay, and so you could really mess around with these beginning and end dates to figure out specific values of principal or specific values of interest for certain periods of time if you're interested. And so this function, this amortization function on this calculator has a ton of potential in terms of helping you figure out values that you may need to know for a specific problem. All right, but with that, that's it for the amortization function. And so let's clear our work and move on to our next topic. All right, so next up we're going to talk about bond valuation. Specifically, I'm going to show you how to calculate the price of a bond in your financial calculator. And so here we have a fairly simple example. It comes from one of my videos where I talk about bond valuation. Again, you can find that video in the playlist linked in the description below. But here we have that a 10-year bond issued for $100 pays 5% coupon semi-annually and yields a nominal interest rate of 6% convertible semi-annually. Calculate the price of the bond. All right, so we know the face value and the redemption value are both $100, right? The bond is issued for $100. We know that the coupon rate is 5% convertible semi-annually, right? That 5% is a nominal interest rate convertible semi-annually, which is why we divide it by 2 to get 0.025 as our coupon rate. And in the same way, our yield rate or interest rate of 6% is convertible semi-annually, and that is also a nominal rate. And so we divide that by 2 to get our yield rate of 0.03. Okay, and then our value of n is equal to 10 times 2 because we have a 10-year bond, but coupons are paid semi-annually, and so we have to multiply 10 by 2 to get our total amount of semi-annual periods, which is 20. All right, so those are all our values. That's where they all come from. And so in order to calculate the price of the bond in our calculator, we're going to be using this row of white buttons once again. It's actually fairly simple. If you've already watched our section on how to calculate the future value and the present value of very basic scenarios, as well as calculating annuities, then this is going to be very easy to pick up. Our payment amount is going to be equal to the face value times our coupon rate. Basically, the payment is equal to the amount of your coupons, which is found by multiplying the face value by the coupon rate. In this case, that's 100 times 0.025, which gets you 2.5. All right, so 2.5 is the payment. Then we know that there are 20 semi-annual periods, so we'll have 20 is our value of n. Our interest rate is going to be the yield rate of 3%, so make sure that you put in 3, not 0.03, make that your interest rate. And then our face value or redemption amount of $100, that is going to be our future value, right? At the end of the term for a bond, the redemption value is also paid along with any final coupons. And so that redemption value also happens to be the future value for this calculation. And so we're going to type in 100, make that the future value, and then we will hit the compute button and calculate the present value. Now, the reason that works, and you'll notice that that is the correct answer, it matches up with our price right here, is that the price of a bond is a present value, right? The price of a bond is equal to the present value of the coupons paid plus the redemption value, okay? So that's why that works. That's why the redemption value is the future value, and we calculate the present value in our calculator. Right, so that 92.56 is the price of that bond, which matches up with our price right here. Okay, and so with that, that's really all there is to calculating bonds in your calculator. Just a quick note that using your calculator for bonds does have a lot of benefits, especially if you're looking for a value that isn't the price. For example, let's say you knew everything but the yield rate. That would be very difficult to solve for by hand because the yield rate is in two places of that price formula. But if you know everything else except for that yield rate, you can plug all those values into your calculator and then hit compute I/Y, and that will give you the yield rate in like half a second. So it's actually really nice if you know how to use it when you're given a problem that asks you for something that's a little bit harder to solve for if you were doing everything by hand. All right, but that's all there is to calculating the price of a bond in your calculator. And so with that, let's clear our work and go on to our final section or final topic of this video. All right, so finally I'm going to show you how to calculate the internal rate of return, or the IRR, using your financial calculator. And so if you watched some of our previous sections in this video, you know I showed you how to use the cash flows button. Well, we're going to revisit that button because that's going to help us calculate the internal rate of return. Remember that calculating the internal rate of return deals with a transaction of net cash flows. And so here I have an example from one of my videos where I talk about how to calculate the internal rate of return, at least by hand, but we're going to do it using the calculator here. And so here we have a set of cash flows where C sub 0 is negative 1,000, C sub 1 is 450, and C sub 2 is 630, and each of those cash flows occur at time 0, 1, and 2, respectively. And of course, we want to determine the internal rate of return for that series of cash flows. All right, and so here's the equation of value we set up when we calculated that by hand. Of course, we then used the quadratic formula to actually solve for I, but it's going to be a lot easier in this case with the calculator. And so what we're going to do is we're going to hit the cash flow button. So let's go over here. Let's hit cash flow. And then we're going to clear out all work. So I'm going to hit second clear. And now we're ready to go ahead and type in our cash flows. So our first cash flow, C sub 0, is negative 1,000. So I'll type in 1,000 and then we'll make it negative and we'll hit enter. Then we'll hit the down arrow. Now we're at C01. That's going to be our next cash flow, or C sub 1, which is 450. So I'll type in 450, hit enter, hit the down arrow. Now F01 is the frequency of that cash flow. It only occurs one time, and so we don't need to change it. It's already set to 1. So I'm going to hit the down arrow again. Now we're at C02, and that is going to be our second cash flow of 630. So I'll type in 630, hit enter, and then the down arrow. The frequency of that cash flow is also 1, so I don't need to change that. And so we're good. All right, so that's the last cash flow. We don't have one for C03 or C04. We don't need to worry about entering any more values into our calculator. Now all we have to do is hit the IRR button, or internal rate of return. And that button is found right here. And so I'll hit that button. And so here it says IRR. And you see up here it says compute. That's telling us that all we have to do is hit the compute button. And there is the internal rate of return of 5%. And so that matches up with our answer here, where I is equal to 0.05, which is the same as 5%. All right, so as you can see, calculating the internal rate of return is pretty simple with the financial calculator. And one of the best things about it is that you can have more than just 3 cash flows and it will still work. If you watched my video where I talked about calculating the internal rate of return by hand, where we used the quadratic formula, I said it wasn't reasonably possible for us to calculate an internal rate of return if there were more than 3 cash flows, just because the equation of value would be so complex to solve. And so that's where the financial calculator really shines, because you can have way more than 3 cash flows and it's still going to be able to calculate the internal rate of return pretty quickly. All right, so this is definitely a very helpful function that you should know how to use. All right, and so with that, that was the last thing that I wanted to show you how to use on the financial calculator, or more specifically the BA2 Plus Texas Instruments calculator, the Business Analyst, I guess it's called. And so if you have any questions, feel free to leave those in the comments below. If there is something that you want to know how to do with this calculator that I did not cover in this video, feel free to let me know in the comments below. Maybe I'll make a follow-up video at some point and cover some extra functions, but I do think that everything in this video is pretty much everything you need to know for the majority of problems that you will come across in a financial mathematics course. All right, but if you have any questions, once again, leave those in the comments. But for now, this is all I had, so I will see you next time.